So, more exercise. Okay, implement a parallel ping-pong program in Python. Two processes pass a message carry a counter back and forth between two rank 110. So start from process 0, and when the message reaches process 1, its counter will be increased by 1 and then sent back to process 0. So how do I show? Oh, sorry, that is a word flag message. So basically what it looks like is, if you are keeping track of that, this is process 0, process 1. There should be a variable called count, start at 0. When you send count to process 1, count become 1. And process 1 would send the same value of 1 back to process 0. So now at 0, count equal to 1. Send equal to 1, count become 2, send it back 2. And do it 100 times. Sorry, this is 99. And at this stage, count should be equal to 100. And you have process 0. Print out the count. So this is what it's how to look like. So at iteration 98, counter process 0 is 99. So at the iteration 98, counter process 199, and at the end of that iteration, at the end of iteration 99, the counter process 1 is increased. This is after the counter process 0 received the input from the counter process 1 back. So this is the answer without all the detailed printout that I have for that. Get rank, counter start equal to 0. For I, the rank going from 0 to 100. I'm just keep sending the counter to the source. I keep sending counter to destination equal 1, and I receive something from destination 1 back. So this send and receive loop just keep running within process 0. Within process 1, you have another for loop in which you keep receiving from process 0 100 times, increment it by 1, and send it back to process 0. And at the end of the for loop in process 0, you print out what the final count is. So I see some of you have implemented as a big for loop outside, and then you have the same body of source code inside. I don't think that there's a different. So it depends. The important thing in writing parallel program, particularly with message passing, is that how you can visualize the communication path among the processes. What does process 0 do? When does it send data to process 1? What does process 1 do? When does it send the data back to process 0? And how you synchronize all of them together. Because let's say if I make a mistake and I do something like this. What do you think would happen? What would happen is that anytime an MPI process go into the receiving mode, it becomes a blocking process. By default, it becomes a blocking process. It's going to wait forever until it receives something. So you can see that with that source code, process 0 will run 100 times, and it finishes, and it brings down final count equal to 100, and that's it. it kills itself. And then in process 1, it still have one more iteration of the loop going to 101, and process 1 start to slide go into the com.receive command, and it just stay there forever, waiting to receive a message that is never going to come because process 0 already finished out of that. So basically, doing the loop separately or doing a common loop for the entire program, just do it so that you do it the way that you think is most appropriate and make the most sense for you when trying to understand how the process communicates with one another. So let's look back at the source code for this a little bit. I want to clarify something. When you start running an MPI program at the very beginning, each process is going to have its own memory space. So anything that process 0 has is not going to be shared with process 1. And in fact, so for example, let's start from the top. Import MPI for Y. Both processes will execute the first line, the second line, the third line, the fourth line. So when it executes that line, within process 1 is going to have some variable called com. Process 0 is going to have some variable called com. This variable, even though they have the same name, are separate from one another. They can have the same name, they might point to different value. And this shows in the second line, let's say your rank. The rank of process 1 is going to equal to 1, and the rank of process 0 is going to equal to 0. Again, the memory space of the processes in MPI are separate from one another. So you kind of have, when you're working with parallel program, especially with MPI, you start to have to develop the skill to be able to kind of visualize what each individual process will have in terms of variable. So at this line of code, if rank equal to 0, so again, both processes have access to the same code, but because of the rank value is different, only process 0 will execute this segment of code. So it declares a counter initialized to be 0. And then it goes into a for loop. So at the beginning, I equal to 0. At the same time, again, because of parallelizations, rank 1 at the same time also start executing. So rank 1 actually might even step into the for loop earlier than process 0. And rank 1 start to create a variable called x, and it is going to wait for information from process 0. So process 0 now send the counter value. Send the counter value over to process 1. This command is going to send something over the network or over the memory space. Send something over the network over here and get written onto it. So this is basically, this is not the same. This is not like you are sending an email. This is more like you are sending a file from one machine to the other. You still retain a copy of a file. The other guy gets exactly the same copy of the file. And at this stage, you increment x by 1, and then you start sending x back to 0. After 0 finishes the send, it goes into the receive mode, and it receives back into the counter. Receive from 1. So this send is going to send the value of x over here, and it will override what counter has originally with the new updated value from process 1. And basically, you go to the next, even though it gets executed again, I increment to, sorry, this is I0. I increment to 1, and this step are repeated until both of them finish with 100 iteration. So if you want to do MPI, being able to understand this is very important. Basically, you are juggling a lot of processes the content in memory of a lot of processes at the same time.